Here we go. We're going to step up the pace just a little bit. Rule 5, are gender and period independent? Okay, so Rule 5 was and means multiply when they're independent. One of the best ways to think about this thing of independence is going to be with tables. Okay, so here's some random attendance or a random number of people per period of the day. I think we've talked about this before. We have our marginal distributions, all our totals around the edges. Okay, and then we want to see a couple of different things. Okay, so let's go and look at each one of these. And most of them are pretty self-explanatory. If you look at the bottom row, maybe that's something that you don't recognize. That notation, at least, you might not recognize. Okay, so what's the probability a randomly selected person is in first period? Okay, well, the number of people in first period, 30. Total number of people, 78. Okay, so the probability random person is in first is going to be 30 out of 78. Awesome. Okay, what's the probability that a random person is female? Well, look at the total females, 44. Out of the total people, 78. And we're done there. Now, here's where it gets a little bit more interesting. Now, what's the probability that someone is a male and also in first period? Okay, well, how many first period males are there? Okay, well, there are only 7 first period males out of 78 total. How about a female in third? Well, there are 8, and that's out of 78 total. Okay, so far so good. It's pretty standard. Now, the one new part is this vertical line. And just like we've been adding some notation, this means given that. Okay, given that, or based on the condition that, okay? So what's the probability that someone, a randomly selected person, is male, given that we know that they're in first period, okay? So what's the probability? Well, given that we know that they're in first period, then that's when we know we're only looking at 30 people total, okay? That's how many we got into first period. Now, how many of those people are males? Just 7. So 7 out of 30 would be our probability that a randomly selected person would be male given that they're in first. Okay, and then go back to the female proportions. Okay, those female proportions, given that they're female, what's the probability that they're in third? Okay, now this is a little bit different. Given that they're female means we're only going to look at this column over here. Okay, so given that they're female, well, that's out of 44. What's the probability that they're in third? Okay, well, that was 8 out of 44. Okay, so that vertical line means given that. Okay, now we're going to get into some of our rules again. Okay, Rule 5, remember, was talking about independence. Okay, so this is if 2 different categories or 2 different events are independent. Then what? Well, then the probability of B given A is just equal to the probability of B. Okay, so you're maybe not sure how that actually helps you or what that actually means, so let me give you an example. The probability that I give everybody 100 on the next test, given that I'm wearing a pink shirt, is equal to the probability that I give everybody 100 on the next test. So whether or not I'm wearing a pink shirt has nothing to do about if I'm going to give you 100 on the next test. If I'm going to, I'm going to. If I'm not, I'm not. It doesn't matter what the color of my shirt is. Okay, so that means that the color of my shirt and you getting a free 100 on the test are independent events. Okay, when they're independent, that's when we go ahead and we can use our rule for and. Okay, remember this symbol right here is for and. So the probability of A and B is equal to probability of A times probability of B. Okay, so nothing real new there. If they're independent, then the probability of B given A is equal to the probability of B. Okay, A and B are completely unrelated. They don't impact each other. Okay, so the probability of A given B, so the probability of A and B is equal to the probability of A times the probability of B. Okay, that brings us to this idea of conditional probability. So again, this idea of probability, conditional probability is based on the idea that you already know something. Okay, now what it always is dealing with, and go ahead, you might want to get this copied down, so the idea of conditional probability. Here's the number one formula you have to know for conditional probability. Okay, and we're going to solve it for different parts of the formula each time, but if you know this formula, you should be good. Okay, so we're always talking about what's the probability of A and B. Okay, what's the probability of A and B? Well, if they're independent, we know we can just multiply because and means multiply. Okay, so what we would be multiplying is the probability of A. Okay, and here's where it gets different. Let's say it's dependent. Okay, they depend on each other. It helps you. Okay, if I'm wearing a pink shirt, maybe it means something. Okay, so if I'm wearing a pink shirt, your odds are good that I'm going to give you a free 100. Okay, so probability of A, and then it's going to be, normally it's just times the probability of B, but now that we know that A is happening, here's your formula right here. Okay, so the probability of both is equal to the probability of first times probability of the second, given that we know the first is going to happen. Okay, go ahead and take about 15 seconds. Make sure you got that part copied down. We're going to look at a couple examples. Then that'll be it for today.